Thanks a lot for your speech.
Thank you. Bye-bye.
Machen wir noch einen Jingle?
Next, back.
Genau.
Das ist vor zurück.
Ja,
Und
da ist ein
das ist so ein Pointer, der ist aber nicht so exakt. Also den sieht man nicht so
ja,
gut.
man sieht es auch da vorne auf dem Screen nicht, deswegen bin ich mal schon.
Ich wäre jetzt soweit.
So welcome again to the next interesting presentation. It will be about hydrogen engine as replacement machine in the construction machinery sector. And speaker is Walter Seidl. He's managing director from EVS. Please applaud him to the stage.
So, yes, I'm from EVS Hydrogen. Thank you for the get the chance to represent our new product. What we are doing is we stay in the past and have a look on the fuel cell and the battery market and see there is a lot of work and a lot of applications. But also what we see is there is a few markets where we'll have the possibility to integrate very difficult systems like a fuel cell or batteries. And what we are doing is our target is to bring a standard combustion engine with hydrogen as a power unit for special markets like the construction machines or power and heat stations and so on. So at the beginning, we see on the automotive market, they make a lot of work by fuel cells and battery electrics. And fuel cells are a good technology, but they have also disadvantages by the environments, by the air and the gas they need. And the battery also is the same, the power density and the lifetime, which kind of machines man can drive. So there are limits. And we have the question, what about special markets? Like construction machines, like off-highway applications and industrial applications. So, and we see how is these two technologies are realizable in these markets. So what is the thing to integrate that big types of fuel cells, the difficult construction? So because special machines are not the same like cars. Cars are designed and there is one room for one technology, but systems like construction machines are much different. So in the past, machines for construction engines are like diesel engines or gasoline engines have a standard construction, and this is the thing in the last 30, 50 years works with this type. So, and this is the question, how is it realizable, how is integratable, and also what is with retrofitable. If you have old machines and we have the target in a few years, we want to have no carbon in the air, and how we do that, how we come to this point. That means also we need a technology to change existing machines with a new technology without any emissions. Yeah, and also in rough environments. So construction machines not working in easy environmentals. It's the thing, you have dust, you have sand, you have a lot of vibrations and so on. And fuel cells are in this application really critical. That means our target is to work with hydrogen. Hydrogen is the best fuel we can have. There is no carbon inside. We have easy that the burning environmentals are very good for combustion engines. So the thing is why we not use hydrogen for this technology. We need zero emission. It have to be fast. So if you, for example, as constructor for a construction machine, you have to integrate it. How long does it take to do that? So if you have the same engine type or near the same engine type, like the diesel engine is integrated in this, it's very easy to change this. You have only the application work for the tank, for example. Yes, it have to be retrofit able. That means to change it on existing machines. Then it have to be more power than the existing technology are. So like a diesel engine or a gasoline engine. And the power density means the volume of the package depend on the power you can spend. So this is also a critical thing to integrate it in these types of construction machines. And from the controlling, you have the same need that the torque control of that type of engine is very important, because every systems around is depend on the controlling like the diesel engine, and also we have to do the same. So our solution is we go back to combustion engines. We not mean that's a critical thing. We have no emissions, and why we not should do that with technology since the last 100 years. We have the solution to have to scale able the power. That means we have a product where we can easy upgrade in more power units and have also the possibility to can scale the power for that type of engine. Then we not want to have a special requirement for the hydrogen tanks. So that means if we have a low pressure system and we can take a new easy gas tank or a gas bottle, it works for every applications. The design has to be like a diesel. It means the case and the panel and the shaft have to be the same, where you can integrate easy different engines. And also it's very important to get a producible small and big volumes. That means the technology have to be the possibility that you can produce it in low volumes or in high volumes. That means you have to take the same technology like the standard automotive market, do it by the parts to produce. And the big thing is we have no requirements for hydrogen quality, like fuel cells. We want to can have the lowest available hydrogen, because it's a standard combustion engine and we have no influence of rough things like sand and so on. So what is the technology? Our technology is we work with a special four-stroke engine, and it's a modified rotor disc engine. We not go on the standard four-stroke engine. The thing why we do that is the power of a four-stroke engine is every 720 degrees. Every second turn we have a power. The thing is, if you do that with a standard four-stroke engine, the power density have to be the same like a diesel. We want to have more power, not less. So in this, if we do that, we have power per revolution. So this is an advantage that we have depend on this technology. Then we want to have a small installation space that we have no issues to integrate it or retrofit abled the engines in the construction machines. Then we have with our technology no problems with the hydrogen combustion speed, because in the normal standard four-stroke technology, the burning speed of hydrogen is a limitation for the mechanical. So this limitation we not have with our rotor principle. But to have a best working on efficiency and so on. We have developed in the last 3 years a special combustion process. And why we do that is we have a longer power pass. And with this longer power pass, we have the possibility to control the burning from hydrogen in the combustion engine. And the last thing, we not want to go back with an old technology. We see that hybrid applications are really interesting in the future. Maybe there are a few markets where it's interesting to have electricity power. So this is the thing why we also integrated our combustion engine with an electricity engine. That means we have a real hybrid engine. I spoke before about the power density. The thing is, if I compare me with a diesel engine, we have to take the same speed, the same construction levels and so on. And what we know is that standard construction diesel engines have around 3.3 kilowatts per 100 cubic centimeters chamber size with turbocharger. The standard stroke with hydrogen fuel reach around 2.8 kilowatts per 100 per seconds with turbocharger. What our level is higher than this without turbocharger, and we have the installation space of 60% of a standard combustion engine. So this is the basic core. Here you see the electricity engine, the combustion engine. We also work with hybrids. That means we can work with the electricity power also integrated. We have 4 modes. We can work as a generator like electricity. We can work also only alone as electricity engine. We have a boost mode. We can combine electricity engine and hydrogen power. And we have the classical starter mode.
So I'm sorry, we have to come to an end.
Okay, sorry, yes. 2 minutes. 2 minutes?
No, we are in time. We have to skip to the next presentation,
Okay.
but you have one last, one last.
Okay, so this is the project. You can see it's constructed like the standard engine. This is the output shaft. Every part is integrated, and this is the type of applications standard for off-highway and construction machines, range extender concepts, and power and heat stations. And this is the power levels we have. We are.
I'm sorry. We are so much in time.
Okay.
I'm really sorry, but I see there is a lot of power in this subject.
Yeah.
And I really would love to follow your presentation. It's not just a saying. And if there are any more questions, come to his booth. It's in D21. D21.